Hello everyone, welcome to Comprehensive Learning. In today's class, we will be discussing about water supply engineering. Myself, Prabhas Shankar VP, Assistant Professor, Department of Civil Engineering, Christ College of Engineering. So question number 1. In which method of population forecasting, increase in population from decade to decade is assumed constant? The answer is arithmetical increase method. Explanation is, in arithmetic increase method, we know that dp by dt is the rate of change of population. So in arithmetic increase method, dp by dt equal to k, where k is a constant. So the answer is arithmetic increase method. Coming to the second question, what is the expression used for population forecasting by the arithmetical increase method? So the answer is B, that is P naught plus n into x, where P naught is the present population, x is the average of the population increase in non-decade, and n is the number of decades. Next is the third question. In which method of population forecast, percentage increase in population from decade to decade is assumed constant? The answer is geometrical increase method. Before we discussed about arithmetical increase method. In arithmetical increase method, increase in population from decade to decade is assumed constant. But in geometrical increase method, percentage increase in population from decade to decade is assumed constant. So the answer is B, geometrical increase method. Then coming to the fourth question, what is the expression used for population forecasting by the geometrical increase method? So the answer is A, that is P naught into 1 plus R by 100 whole raised to n, where P naught is the present population, R is the average percentage growth rate per decade, and n is the number of decades. Next, question number 7. Logistic method is also called as, first one, arithmetical increase method, second, geometrical increase method, third one, incremental increase method, and fourth is decreased rate of growth method. The answer is decreased rate of growth method. If you remember the logistic curve, it shows the percentage increase in growth rate as well as the percentage decrease in growth rate. So the answer is D, decreased rate of growth method. Coming to the 8th question, consider the following statements. There are 3 statements. First one, arithmetical increase method is suitable for new cities. Second one, decreasing growth rate method is used where the rate of growth shows a downward pattern. And third one, geometrical increase method is suitable for older cities. And we have 4 options. The answer is C, only 2. That is, the second statement is the only correct statement. The first statement, the arithmetical increase method is suitable for new cities. Actually, it is wrong. The arithmetical increase method is suitable for older cities. And the third statement, geometrical increase method is suitable for older cities, is wrong. Actually, the geometrical increase method is used for the new cities. So the only correct statement is statement number 2. Next, question number 9. Which method is suitable if the growth rate is decreasing and the population is reaching towards saturation. We have four options. First one, arithmetical increase method. Second one, graphical comparison method. Third one, zoning method. And fourth one, decreased rate of growth method. The answer is D, decreased rate of growth method. In decreased rate of growth method, growth rate is decreasing and the population is reaching towards the saturation. And this method is only valid when the growth rate shows a downward pattern. So the answer is D, decreased rate of growth method. Next is the 10th question. Which method of population forecast is suitable when extension is required for small duration and past record is available for long duration? There are four methods: graphical comparison method, graphical extension method, logistic curve method, and zoning method. The answer is B, graphical extension method. Graphical extension method is a method where a curve is drawn between population and time up to the present period. Then the curve is extended from present to the future decade and the population is approximately determined from the extended part of the curve. So graphical extension method is the best suitable method when extension is required for small duration and past record is available for long duration. So the answer is B, graphical extension method. Next, question number 11. The average quantity of water in Ipcd required for domestic purpose according to the IS code is, there are four options. First one 100, second one 120, third one 70, and fourth one 135. The answer is 135 Ipcd. The average domestic water demand in India is 135 liters per capita per day, and for the developed countries it is around 340 Ipcd because they live a luxurious life. In India it is 135 Ipcd. Question number 12. The average consumption of water required in factories in Ipcd is, we have four options: 10 to 15, B 20 to 30, C 30 to 45, and D 70 to 80. The answer is C, 30 to 45 Ipcd. The average water consumption in factories is 30 Ipcd when no bathrooms are required and 45 Ipcd when bathrooms are required. So the answer is 30 to 45 Ipcd. Next one, question number 13. In which type of water demand minimum average consumption of water takes place? We have four options: domestic water demand, industrial water demand, institutional and commercial water demand, and fourth one fire demand. When comparing all these four types of demand, we have fire demand have the minimum average consumption of water. So the answer is D, fire demand. It accounts to 1 Ipcd, that is very less quantity, but this water is required in very less duration because the fire demand is required when the fire breaks out. So that much small quantity is required, but it should be available in a very shorter duration. Coming to 14th question. What is the minimum water pressure available at fire hydrants? So fire hydrants are used for extinguishing the fire. So we have four options: 80 to 100 kilonewton per m square, 100 to 150 kilonewton per m square, Third one 40 to 60 kilonewton per m square. And last one 150 to 200 kilonewton per m square. So the answer is B, 100 to 150 kilonewton per m square. That is around 10 to 15 meters of water head, and it should be maintained for 4 to 5 hours. So the answer is 100 to 150 kilonewton per m square. Next, question number 15. Match list 1 with list 2 and select the correct answer using the codes given below, where Q is the quantity of water and P equal to population in 1000. And list 1 contains the names of the formulae, and list 2 contains the formulas or the equations. So first one, in list 1, Kuchling's formulae. We know that Kuchling's formula is given by Q is equal to 3182 root P. Freeman's formula is given by Q equal to 1136 P by 5 plus 10. Buston's formula is given by Q is equal to 5663 root P, and central congested high value set T equation is given by Q is equal to 4637 root P 1 minus 0.01 root P. So the table is already given in a matched state. So the answer is A. The answer is A. Also, the Kuchling's formula is used when the population of the cities exceeds 50,000, and when the population of the city is less than 2 lakh, central congested high value city equation can also be used. Sixteenth question. What is the fire demand of the city of 1 lakh population by Buston's formula? We have got 4 options. The Buston's formula is given by Q is equal to 5663 root P, where P is the population in thousands. So here the population is given as 1 lakh. So converting it to thousands, it will be 100 thousands. So the value of P is 100. Then root P will be 10. So 5663 into 10 will be the population. So the answer is B, 56,630. Next is the question number 17. Water lost in theft and waste contributes to how much percentage of the total consumption? We have got 4 options. First one is 5, second one 10, third one 15, and fourth one 20. The answer is 15% of the total consumption. This also includes the water loss due to leakage and stolen due to illegal connections also. Okay, so the answer is C, 15% of the total consumption. Next is question number 18. What is the design period for the water treatment unit? Design period for the water treatment units. We have got 4 options. A, 10 years, B, 15 years, 3 or C, 20 years, and D, 30 years. The water treatment unit is designed for 15 years, and its design discharge is maximum daily demand. So it is designed for the 15 years. So the answer is B. Next, question number 19. Which is the correct statement regarding per capita demand? A, daily water required by an individual. B, water required for various purposes by a person. C, water required by an individual in a year. And D, annual average amount of daily water required by one person. So the definition of per capita demand itself is annual average amount of daily water required by one person. So the answer is D, annual average amount of daily water required by one person. Coming to question number 20, what are the factors affecting per capita demand? A, size of the city. B, size of the city and habit of the people. C, cost of water, quality of water and size of the city. D, cost of water, quality of water, size of the city and habit of the people. The answer is D. All these factors will affect the per capita demand. If the cost of water is high, the consumption will be low. If the quality of water is good, then the consumption will be more. If the size of the city is big, there will be more consumption because the population will be more. And the habit of the people. Habit of the people also affects the per capita demand. If they are living in a luxurious life, the consumption will be more. And if they are living in a underdeveloped or less luxurious life, the consumption will be less. So all these factors will affect the per capita demand. Next one, question number 21. Which of the following statement is correct? A, rich class consumes less water. B, intermittent water supplies lead to less water consumption. C, loss of water is more if the pressure in the distribution system is less. D, water consumption is less in flush system. The answer is intermittent water supplies leads to less water consumption. Actually, the rich class consumes more water because of their style of living. And intermittent water supply leads to less water consumption. That is actually correct. If we have a continuous supply, we have a tendency to consume more water. And if we have a intermittent water supply, we will store more water and we will be effectively using the water without any leakages, or we will be consuming less water. And see, loss of water is more if the pressure in the distribution system is less. Actually, if the pressure in the distribution system is less, the leakages will be less, so the loss of water will be less. Then water consumption is less in flush system. If we are using the flush system, the water consumption is actually more. The only correct statement is B, intermittent water supplies lead to less water consumption. Coming to question number 22. If the annual average hourly demand of the city is 10,000 m3, what is the maximum hourly consumption? So the maximum hourly consumption is given by 2.7 times average hourly demand. So it will be 2.7 into 10,000. So the answer is B, 27,000 m3. Then question number 23. If in a city the maximum daily draft is 25 mld, fire draft is 35 mld and maximum hourly draft is 40 mld, what is the coincident draft? So coincident draft is given by the maximum of, or the highest value of, maximum daily draft plus fire draft, that is 25 plus 35 equal to 60 mld, or maximum hourly draft, that is 40 mld. So the highest among these two, so that is 60 mld. So the answer is 60 mld, A, 60 mld. Next is question number 24. What is the design discharge for intake structures? We have got four options: maximum daily demand, maximum hourly demand, maximum weekly demand, and last one, average daily demand. Intake structures and the pipe mains that carry water from intake structures to the treatment plant are designed for maximum daily demand. So the answer is A, maximum daily demand. And the last question, in which of the following units design period is maximized? So we have got four options: distribution system, demand reservoir, water treatment unit, and pipe mains. So in which of these four design period is maximized? The answer is demand reservoir. The distribution system is designed for 30 years. Demand reservoir is for 50 years. Water treatment unit is for 15 years. And the pipe mains for 30 years. So the design period is maximized for demand reservoir. The answer is B, demand reservoir for 50 years.